The goal of Arsenal is to reduce casualties sustained by search and rescue personnel and increase survival rates. 4 bots make up the swarm: the locator, which locates wounded and alerts Central Command; the obstacle eliminator, which removes elements delaying the team; the supplier, which carries bandages and rations; the transporter, which carries the wounded to safety. Transporter is able to communicate with others in swarm and central hub. When given signal, it will deploy to victim location, and when loaded, will transport victim to safe location. In this presentation, the transporter will be covered in greater detail. The bot is 1.2 meters long when in non-transport mode and 3 meters long when in full transport mode. 2 DC motors connected to axles through the frame power the wheels. Ultrasonic distance sensors located on the front and back relay distance data. A drawer houses batteries and Arduino in the bottom and provides extra storage. Free moving rings slide over expandable frame and safety pins engage. Screw clamps hold canvas to the frame. A better view of the expandable frame can be seen at the bottom and top. This simplified circuit shows the connections between sensors and actuators. The HC-SR04 will send data to the bot and central hub. Parameters are set for the DC motors, and using the data received from the HC-SR04 will determine how the DC motors react. The bot is initialized and serial communication starts. If no obstacle is within 20 inches, then the bot will await command. Once a command is received, the bot performs given tasks associated with that command and returns to original loop. Here, the Arduino code is displayed. Utilizing a combination of serial commands and if statements, the bot is able to perform the tasks needed. The rest of the Arduino code. Displayed here are 2 DC motors for the front left and the front right. The additional motor on the bottom will represent both the left and right rear. The distance sensor will represent all 4 distance sensors that the bot has. When the bot is initialized, distance data will begin to be sent to the central hub, represented here by the serial monitor. If the distance is greater than 20 inches, it is just the distance. If it is less than 20 inches, an obstacle message will appear, at which point a reverse message can be sent, and the command will have the bot go in reverse, backing you away from the obstacle. If the reverse command does not fix the situation, then a obstacle removal bot will be sent a message from Central Hub to remove the obstacle. Once the reverse command is completed and course correction is done, or course correction is not needed, a begin command can be sent, at which point all the motors will begin to move forward. The bot is programmed to move forward until an obstacle is within 20 inches, at which point all motors will stop, and again a reverse command can be sent. At this point we can turn right, turning the right motors in reverse and the left motors forward, and we can turn left, which does the opposite, turning the left motors in reverse and the right motors forward. We also have a stop function, which when the motors are moving in reverse or in going forward, will halt all movement and display a non-standby message. Finally, we have the extend command, which when not given an adequate space, will display a space inadequate message. But once 71 inches, the parameters at which it is set, has been met, the front motors will move forward and the back motors will move backwards, extending the canopy. If the bot does not receive any commands, it will stand still and just display distance data. In summary, the transporter is able to relay information as well as receive commands to perform given tasks. The bot has the ability to extend to 3 meters in transport mode to accommodate for persons of all sizes. And finally, the bot is able to work collectively with units in the swarm to effectively complete search and rescue operations while increasing survival rates and decreasing casualties of search and rescue personnel.